Good day. In our last class, we discussed continuity of functions. Earlier, we have said continuous function is an equation given by this. So, what this equation means is that if a function f of s will be continuous if this f of a is defined. Two, if the limit of f of s exists. And three, both this and this are equal. And we have also given several examples of functions that are continuous. We have earlier said that all polynomial functions are continuous. We have also said that the function sine x, cos x, exponential x are all continuous in the domain of R. We have also said that the function ns is also continuous for only positive number. Okay, so any number outside this range, okay, for the function ns is not continuous. We have also said that the function tan x is also continuous everywhere except at some point. These points are positive or negative pi over 2, positive or negative 3 pi over 2, positive or negative 5 pi over 2, and so on and so forth. So today, we want to look at some examples of discontinuous function. Okay, when we say discontinuous function, this can be classified into three parts. The first part is known as removable discontinuity. Okay, so this example of discontinuity arises when we have a function which is discontinuous at a particular point, but when we define the function, okay, so and that function now has a limit, then we'll say such a function is a removable discontinuous function. Example of this function is the function f of x equal to x squared minus 3x plus 2 divided by x minus 1. In this function, we'll see that f of 1 for this function is not defined. This is so because if we substitute 1 into this function, we see that the answer to this is not defined because we are going to have 0 at the denominator. Okay. However, if we find the limit of this function, when x tends to 1, we see that the limit of this function, after rectification, the limit exists because this will be given as the limit when x tends to 1, x minus 1, x minus 2 divided by x minus 1. Okay, here x minus 1 is cancelled out, and then we are now left with the limit of x minus 2. So when we find the limit of this, when x tends to 1, see that the limit of this is a negative 1. Okay, so after defining the function, we find that the limit exists. Okay, so this is so because we have been able to remove the point of discontinuity at the condition 2. Okay, so what this is telling us is this. This is saying this function cannot be written in the form f of x equal to x squared minus 3x plus 2 divided by x minus 1. This will be this if x is not equal to 1. And this will be negative 1 if x is equal to 1. Okay, so we want to see this on the graph, how it looks like, and what is the point, or where do we remove the point of discontinuity. Okay, so this is point 1. Okay, if x is tending to 1, either from the left or right. Okay, the graph of this function is this. Okay, so at this point, when x tends to 1, okay, the point that was removed is this point on the line. Okay, and this line is representing the curve x squared minus 3x plus 2 divided by x minus 1. Okay, so this is what we refer to as this function as a removable discontinuous function. Okay, so another example of this function under this removable discontinuity is a function that is given as follows. If you are given a function f of x equal to x squared minus x minus 2 divided by x minus 2 if x is not equal to 2, and then this function is given as 1 if x equal to 2. Okay, here again, from our definition of continuity, we'll see that f of 2 is defined. Okay, it is defined because if we substitute 2 here, according to the definition of the function, this is 1, so it is defined. Okay, secondly, we'll see that at 2, this gives us an indeterminacy form. But when we define this function, the limit of this function when x tends to 2 will be given as the limit x minus 2 x plus 1. That's for the numerator. So the denominator is x minus 2 when x tends to 2. Okay, so we'll see that this x minus 2 cancels out this, and then we are now left with x plus 1. So if we substitute this 2 into what we have left, this will be 2 plus 1, which is equal to 3. Okay, so from the second condition, we have that the limit exists and it is 3. Okay, so the third part, f of 2, according to the function, we have said it is defined, and the solution of this is 1, whereas the solution for condition 2 is 3. So here, f of 2 is not the same thing as 3. Okay, so because of this, we say, though it is removable here, but since we redeem it here, okay, so we cannot call it a total discontinuous function. We will refer to it as a removable discontinuous function. Okay, another example of discontinuity is what we refer to as infinite. Okay, so that will be given as part B. Okay, infinite discontinuity. Okay, an example that this is an example f of x equal to 1 over x squared. Okay, so at x equal to 0, we'll see that. Okay, let's define this function as in two forms. So if x is not 0, so if x is 0, okay, this is 1. Okay, here again, by definition of continuity, okay, f of 0 here is defined. F of 0 is defined. Okay, 2, when we find the limit of this function when x tends to 0, we find out that the limit of this function, okay, is not defined. Okay, so because of this, okay, the answer here when we substitute x equal to 0 here give us infinity. Okay, you see that the limit does not exist and it is what? It is infinite. Okay, and however, this and this are not the same. Okay, so because of this, we refer to this as infinite discontinuity.